So waves can be split up into two different categories, transverse and longitudinal waves. So let's take a look at transverse waves first of all. So the transverse wave, we can represent it on a piece of string and it would look something like this. And good examples of transverse waves are things like light waves or water waves. So waves that you see on the surface of water. And the key definition of a transverse wave is that the direction of energy propagation is perpendicular to the oscillations. Okay, so if we were to write that down, the oscillations perpendicular to the direction of energy transfer. Okay, so that's transverse waves. Next, we can look at longitudinal waves. A longitudinal wave we can represent on a slinky or a spring. And what you see with a longitudinal wave is you might have your slinky like this, is bunched up over here, and then it spreads out, and then it bunches up again, and then it spreads out. And so what these sections are called is compressions and rarefactions. So this would be a compression, and over here you would see a rarefaction. So that's the bit where it spreads out. And so the definition of a longitudinal wave is basically the opposite of the definition of a transverse wave. And so for a longitudinal wave, what we'd say is that the oscillations are actually parallel to the direction of energy transfer. And by oscillations, what we mean is just essentially the vibrations that cause this wave to happen. So for the longitudinal wave, the oscillations would be up and down, but you can see the energy transfer is actually going this way or this way, so right or left. Whereas for the longitudinal wave, the vibrations are right or left, and the energy transfer is also in the same direction. So basically they'd be parallel. Now, good examples of longitudinal waves are sound waves. So sound waves are all longitudinal. Now it's important to note that for both transverse waves and longitudinal waves, it's not the actual matter that's being transferred. So for example, we said water, it's the water itself is not being transferred, but it's the energy that's being transferred. Same for longitudinal waves. If you have sound in air, it's not the air that's being transferred, but the energy from the sound waves that are being transferred. And a good way we can prove this is, well, let's take the example of water. So in water, if you were to take a bucket of water and you put a wave in it, you have a still bucket of water, then you put a wave in it, and the wave might look something like this. Now, if it was the water that was actually being transferred by this wave, then what you might expect to happen is that because the wave is being transferred in this direction, in our example, then all the water would gather over here and you basically have no water on this side. But actually what happens is the water pretty much stays in the same place and you just have this wave over here. And that tells us that it's not the water being transferred, but the energy from the wave itself. And we can do the same thing with sound. With a sound wave, you might have a speaker over here, and in your speaker, you might emit all these sound waves. And the thing is, if it was the air that's actually traveling, so the sound waves travel in air, but if it was the air that was actually moving, then what would happen is you'd get a vacuum developing in front of your speaker because all the air is being moved away. But actually that's not what happens, which tells us that actually it's not the air that's moving, but it's the sound wave, it's the energy that's being propagated instead. Alright, so let's get into some questions to see what you remembered then. So question 1, what is the difference between a longitudinal and a transverse wave? So pause the video, have a go. So by definition, a longitudinal wave has oscillations parallel to the direction of energy transfer, whereas a transverse wave has oscillations perpendicular to the direction of energy transfer. That's the definitions, and that's how you would define them, and that's the fundamental difference between them. Question 2, what type of wave is light, sound, and ripples on water? So light is an example of a transverse wave. Sound waves are an example of a longitudinal wave, and ripples on water, we said, were also an example of a transverse wave.